Topic 6.6, creating a table of values. We can represent a relation in different ways. For example, consider this relation. X is related to 20 minus 3x. We can create a table of values, an input-output table, like this. When the change in both the input and output is constant, that is, it changes at the same rate. For example, over here, we have an increase of 1 every time, and on the right-hand side, we've got a reduction of 3 every time. When on both sides of the table, that change is constant, the relation is known as a linear relation. So, for example, if we took the number 1 and plugged it into this original relation over here, so 3 times 1 instead of 3x, 20 minus 3 times 1, which is 3, would equal 17. Okay, and if x was 2, 3 times 2 would be 6, 20 minus 6 is 14. And so it goes all the way down the table. Now, if we understand the linear relation and we know that it is linear, that is, that the change is constant, then it helps us identify values that we don't know. So if we have, let's say, a value of x that is 5, and we want to know what the output value is, if we understand that pattern, we know that it reduces by 3 every time. Well, we could take this number 8, we could reduce it by 3, and we'd know that this would be 5. So when x is 5, the output would be 5. When x is 6, the output would be 3 less than the 5 over here, which would be 2. And so on. Down here would be -1. Now, a table of values can be represented with an x representing the input column and a y representing the output column. And if you look at these examples, let's take number 1. Y is equal to 2x. When the input is 1, we take the number 1 and we substitute it for the letter x. Okay, 2 is multiplied by the letter x, 2 x's. So 2 times 1 would equal 2. So when the input value is 1, the output value, y, would equal 2. And so it goes with the rest of the table. So when x is equal to 2, we take the number 2, we put it in place of the x. 2 times 2 is 4, y is equal to 4. Now, the neat thing about a linear relation is as long as you've done things properly and these two numbers are correct, the difference between those two numbers, because it's a linear relation and we know that the difference is going to be the same every time, is going to be just that, the same every time. So we can simply fill this in, 6, 8, and 10. And we can always double check and make sure that that's correct. So 5, when x is equal to 5, plug the 5 in there instead of the letter x. So 2 times 5 would be 10. Y would equal 10. And that's what we've got over here. So every time here the pattern would be plus 2, plus 2, plus 2, and so on. On the other side, we've got plus 1, plus 1, plus 1, plus 1. That's what's so special about a linear relation. So let's try the next one. Y is equal to x plus 3. So when the input x is 1, what would the output be? Well, we take the number 1, put it in place of the x. So y is equal to 1 plus 3. Well, 1 plus 3 is 4, so the output in that case would be 4. And let's go ahead and do number 2. So when x is equal to 2, we would change this to 2. 2 plus 3 would be 5. Y would equal 5. Okay, now we can look for a pattern here, or we can just keep plugging in these values for x and determining what it would be. So what do you think this would be? According to our pattern, it should be 6. Well, 3 plus 3 is 6, so that would be right. If x was 4, 4 plus 3 would be 7. And if x was 5, it would be 8. Not sure why that's not drawing that line for me. There we go. So there you have it. Increase by 1 on this side, increase by 1 on that side. How about example 3? Y is equal to negative 2x plus 3. Well, the principle is the same. The relation is just a little more complicated. So just be careful. Plug in the value for x. So in this case, negative 2 times 1 would be negative 2, plus 3 would be 1. If x were 2, negative 2 times 2 would equal negative 4, plus 3 would be negative 1. And 3, negative 2 times 3 would be negative 6, plus 3 is negative 3. Again, once you get the pattern, it's going to continue. So looks like we're subtracting 2 here, subtracting 2. So we'd be doing the same thing here. This should be negative 5, and this should be negative 7.